So with the basic parametric truss grasshopper definition under your belt, we're going to start talking about different variations, and this is another of them. This is the curving truss, and you see a little bit of a screenshot here of how the definition is modified. We start from the basic parametric truss definition and then change its utility. You'll see that some of these components are orange. In fact, all of the shortening that we've done with the trim slider is actually not functioning, and you see that I've highlighted here on the left that the trim slider is in purple. That is not working anymore. Neither is the length, because we are not generating the initial line used for the top chord within Grasshopper. In this case, we are importing a curve from Rhino. And in Rhino, I can take that curve and I can use control points or scale. Perhaps I'll actually use the gumball to scale that curve. And I can take it and scale it in the X direction to make it longer or shorter. And you see that the truss, the curve that I've created, responds. So it does move it away from the origin. So my favorite, starting point 0, 0, 0 is not working so well. But this is a very flexible thing, for which we can still change the number of panels very easily. And we can also adjust the depth of the truss from a very shallow to a very deep truss. So this is different. You do need a curve in Rhino in order to make this happen. And so that's the modification that I'm going to run through in this video. And that curve is imported into Rhino up here with this curve bucket. So first I'm going to go back to the original definition that we've worked with. And you can see here in the Rhino window that I do have this new piece of geometry, which is a simple curve. It's an arc. It is on the YZ plane that I've drawn. It's linear with collinear with the line that we used originally to create this truss. And I have loaded into this. I've drawn this arcing curve in Rhino, and I can adjust it with the gumball here, but it has no geometry from Grasshopper associated with it yet. And we're going to do that quickly and then make the necessary changes to this definition so that it can work. And then you want to save it with a new name, because it will be essentially a new definition. So I have the definition that you've already created. It still works. And in all of its different capacities, the trim and whatnot, right, still are functional. The first thing we're going to do is replace the geometry creation up here where we made the SDL line to start with before, and instead we're going to import this curve from Rhino. So we're going to go to the Params tab, and we're going to get a curve bucket. Contains a collection of generic curves, right? We call these a bucket. They're not creating curves, they're collecting curves. And so I can take that and I can right click and set one curve, or if you have a definition that needs more than one curve as an input, you can set multiple curves. I'm going to set one curve. It ships me over to Rhino where I will click on that curve. And so now these are connected. You see if I click on that curve bucket, this curve in the Rhino window is also highlighted in green when I click on each one. Now we're going to substitute that for this top chord, and we're going to start to put it into the definition. But instead of the move, which is not going to be working for us anymore, we're not going to simply move that downward because it's a curve. Moving it won't help us very much. We need a new component. So I'm going to make a little room for myself here by moving these upward just a bit on my canvas. And I'm going to put in an offset curve command. So not offset surface, but offset curve. And we're going to put this new curve into it as its input. And I'm going to give it the distance for the offset being the depth, right? So this now is going to come up here. To create a new curve, and you see it in the left-hand window here. It is offset straight down, and it is it is controlled by this depth. So you can see the green curve moving up and down with the still existing bottom chord of the truss. And now we're going to start to feed the data from this into the different parts of our definition where it needs to go. And in doing so, we're going to also be disconnecting wires for other portions of this, which will no longer be necessary or useful for us. The first thing I'm going to do is connect this curve to the divide over here on the right, which will allow it to become the generating geometry for the points that will be the top elements of the truss. Now, it looks like you could almost run this truss with a curving top chord and a flat bottom chord. The problem is that the bottom chord is still tied to a length which we don't really have related to the top chord, now the curving arc. So we're going to start to replace its input in other ways so that this will become a purely curving truss. So we have the top chord subdivisions connected in. The next thing we're going to do is take the offset here, which is now the bottom chord, and bring it down to connect to the bottom chord divide. And you'll notice that something seemingly crazy happens, which is that it makes diagonals all over the place, right? One of the things to look for is the fact that our number sequence here, we're still displaying the point numbers, is in fact reversed again. So it starts from 0 to 7, and then instead of starting again at the near end with 0, it starts at the far end with 0 and goes up to 6. Because we still have the reverse in here, right here, after that divide, which we needed when we created the line previously, but we don't need anymore. So I'm going to just delete that and connect these points directly to that point bucket. And you'll see now that just switching the numbers of the bottom chord divide makes these diagonals work perfectly as they should. So in the previous case, remember, we could have either created the line in an opposite way for the bottom chord by simply switching these two inputs, but instead we put this reverse component in here. And that was the thing that caused this to look funky. So we've taken that out of the equation. Now things are starting to look good. All we have to do now is not pipe this old top chord, the straight top chord, and instead take the top curve and have it pipe. So we'll bring it over here. And I did not hold down shift, so it took away the previous input, and so now it is the thing generating, it is this curve up here is generating the top chord pipe, as we see. And we need the bottom chord, which is the offset of that curve, also to be piped. So we're going to take that and hold down shift and input that to this pipe command at the end. And we have the top and bottom chords now piping correctly. And what you'll notice is that a lot of what's going on here in terms of some of the functionality that we had needed to build in to the previous example really is not necessary anymore. In fact, there's a whole range of these components that are doing nothing because they don't have the input that they need. In fact, if I disconnect the move command that made the bottom chord, you'll start to see that the original line that we created is isolated. The length is not doing anything for us anymore. It is changing the length of the bottom chord, the move, but it's not something that is part of our definition right now. So I could either delete, in this case, things like this left slider and all of the elements that created that first line. You'll notice these components that turn orange are no longer being used, and those could be deleted. We also, the trim is not functional anymore, and that's fine, so we could delete that. And you could look at the orange components, and similarly, all of those could be deleted because they're not doing anything. But what we have is a new and very robust definition that takes advantage of an input arc as its primary geometry, where I can still control the depth of the truss and the number of panels very, very nicely. And going back into Rhino, I can click on that curve and I can scale it, I can use endpoints, I could even substitute a different curve in order to take this and make a series of different curved or arched trusses that still maintain the parametric utility of this in what's almost a kind of slimmed down version of our original definition, but that's still very powerful and that does a lot for us. So that is one variation, and we've seen others, and we will see more of these as we go. But remember, once you've changed the original definition and taken away elements of it, you need to save it with a new name and save that Grasshopper definition file separately. In this case, I call it curved video because this is a definition I'm using to make the video. And you might want to save the Rhino file as well that will have essentially in it only this arc. It'll have one piece of geometry that's necessary to be put in here. But keep in mind as well that you could run this Grasshopper definition with a different Rhino window, a different Rhino file, and that Rhino file could be even your existing water park where you've drawn an arc on a new layer and you import that arc. You reach over here and you right click on that curve bucket and you say set one curve, and you reach back into a much larger or different Rhino file and click on a curve. It needs to be on the YZ plane, so you're going to have to, orientation matters. But it will take that geometry and produce a truss that you could then bake into that file using this Grasshopper definition. But again, remember, don't just make these changes and then exit out of here, because you will have lost your original or whatever the source definition was that you started from to add things to and to remove things from, and you don't want to lose your work. So do a file, save as, and give it a new name. Thank you.